welcome back to this video. In this video, we shall continue our study in chemistry by looking at the second topic, which is called particulate of matter. This topic covers diffusion and the kinetic theory. And in this video, we shall look at the kinetic theory of matter, heating, and the cooling curves. So, to begin with, let us define what matter is. Matter is anything that occupies space and has mass. And anything on this universe occupies space and has mass. So everything is matter. Anything you can think of is matter. Whether air, water, or anything is matter. So matter is anything that occupies space and has what? And has mass, and has mass or matter. Now, this matter has got what is called states and units. So do not confuse states of matter with the units of matter, right? So the states of matter are the forms in which matter can exist. So matter exists in only three forms with an introduction of the fourth form, which is called plasma, right? So matter has got three states of matter. So if you're looking at the states of matter, we have three: solid, liquid, gas. But an introduction of a new state of matter has been done, which is called plasma. And then if you are looking at units of matter, we have three units of matter. Number one is called atom. Number two, we have ion. Number three, we have molecule. So these are the what? The units of what? Of matter. So please do not confuse states and the units of matter. So in our study today, we'll begin this class by looking at the basic units of matter, which is atom, ion, and molecule. So an atom will be described further in the topics that we are looking at, that we'll look at, but I'll only look at it briefly. The same with ion and a molecule. So an atom is more like a building block of matter, more like blocks that we use to build the house. One block cannot build the house, so we need a lot of blocks. The same thing that happens for matter. For matter to exist, you must build it using small bricks. So this atom cannot be split, or is the simplest form of this atom. So by definition, an atom is the smallest particle of an element. Now, what is an element? An element is a substance that cannot be split, or let me use the word pure because these are pure. It is a pure substance that cannot be split any further. Example of an element is carbon. Carbon is an element and it cannot be split further, and it is also pure. So a pure substance that cannot be split further is what is called an element. So inside this carbon is what are called atoms. So atoms are what make up this carbon, or the smallest particle of this carbon. So this atom consists of three subatomic particles as well. So these subatomic particles are what are called protons, neutrons, and electrons. So under this study, we'll just look at it on the surface and not go into the detail of what are the charges and the masses of these protons, neutrons, and the electrons. Then what of an ion? An ion is a charged particle that is positively or negatively charged. So I'll just look at an introduction as well. And then if you're looking at a molecule can have two definitions. For example, if you get carbon plus carbon and then get C2, this is a molecule. If you get carbon plus oxygen and then get CO2, this is also a molecule. So a molecule is a combination of two or more atoms chemically of the same what? Element. It can also be defined as the combination of two or more atoms of different elements. So do not confuse the two. Next, let us look at the states of matter, which is solid, liquid, and gas. Now, what must we know under the solid, liquid, and gas? We must know how the particles are arranged in a solid, liquid, and gas. That is to say, we are now looking at the kinetic theory of matter. So, the kinetic theory of matter is a theory that explains how the particles of matter are arranged. So, the kinetic theory of matter states that matter is made up of tiny particles, and it also states that these particles are in constant random motion. And then the third point under the kinetic theory of matter is that when you add temperature to a substance, the vibration of the particles increases. And that's normal because temperature is defined as the average kinetic energy of particles, or how hot or cold a place is, which is a basic definition. So if you have these particles, let's assume this is water that you have put on the pot. If you begin to increase the temperature by heating it, what will happen is that these particles will begin to move faster and faster, and it will reach to a point whereby they will move very fast and they will begin to evaporate. So that is what the third point under the kinetic theory of matter explains. It says if you increase the temperature, that is the average kinetic energy of the particles, what will happen is that those particles will change their state or begin to vibrate more, right? Because of course you've increased the temperature. And it says that the opposite is true. When you reduce the temperature, the vibration of the particles will do what? It will reduce. Now, let us see how the arrangement of these particles are. Or you can also say this kinetic theory of matter states that matter is made up of discrete, or discrete means the tiny particles. So I've just used the word tiny here to be general. So let us look at how the arrangement is in solid, liquid, and gas. So look at the arrangement and then also the volume. So, say shape, volume. Now we learned in lower grades to say volume is the amount of space occupied by an object. So I want you to keep in mind, even as I'm filling up this table. So how are the arrangement of particles in a solid? For you to identify that this is a solid, it must have particles being very close to one another. So they can put the particles on one part there, or they can fill it up. But all you have to know is that the particles do not have to have space in between them. It has to be completely what? Completely filled. So how do you describe the arrangement? You say they're fixed. The particles are what? Fixed. In liquid, the particles are not fixed. And also in gas, the particles are also not fixed. Why? Because if you heat up a solid, what will happen is that it will not start melting there and then. If the particles will begin to vibrate about their what? about their fixed position when you heat it. If you are looking at a liquid, on the other hand, the particles in a liquid slide past one another. So it's more like they pass one another like that. So they slide past one another because they have a little space in between them. Not saying that they have a lot of space. And that also explains why these are able to flow. For example, water. Because of what? Because they can slide past each other. Then we have gases. Gases have got very far very far distances, which gives them a no fixed shape, no fixed arrangement as well, because they are further apart each other and they can move anywhere. That also explains why a gas can fill up any container you put it into. So if you take a gas from a container that is like this and then put the same volume of the gas in this container, you'll be able to fill up this container, because what? Gases do not have a fixed arrangement. Then what of the shape? The shape will be the same as the arrangement, because these solids have a fixed what? Shape. They only vibrate about their fixed position. Then these liquids do not have a fixed shape. Remember, if you have a cup here, you put water that reaches on this level. Then you get this same amount of water and put it in a cup, in a plate, on a plate that is like that. It will be able to take the shape of this plate. So it does not have a what? A fixed shape. The same applies for a gas. A gas does not have a fixed shape as well, because it can fill up any container that you put it in. Finally, we have the volume. If you have a solid, let's say you have this uh, the lid of a mug. If you are to put it in a cup, its shape won't change. Why? Because the particles are very fixed. So its volume will also not what? Change. That means that solids have a fixed volume. Liquids also have a fixed volume, because despite you getting this from this container and putting it in this container, it will not change the amount of water there is. What will only change is the shape. So that means that liquids also have a fixed what? Fixed volume. And then what of gases? Gases do not have a fixed volume. They also do not have a fixed shape, because they can fill up any container that you put it in. So if you have a volume that is like this and it fills up a volume that is like that, it means that it doesn't have a what? A fixed volume. Then we end this video by looking at the changes of states of matter, and how these changes of states of matter will cause the release or gain of heat. That is an endothermic and exothermic reaction, looking at the heating and the cooling case. When the gun, yeah. So let us look at the changes of states of matter. So we'll use this to understand the changes of states of matter. All right. So we have about 6 changes of states of matter. The first one is a state of matter where a solid changes into a liquid. For example, ice changing into water. Now, what causes this? What causes this is an increase in temperature. If you increase the temperature, it will cause the particles in the solid to gain kinetic energy, which will convert them into a what? Into a liquid. So an increase in temperature will cause this process of changing from solid to liquid, which is called melting. So melting is as a result of what? Of an increase in temperature. And you can refer to this as an endothermic reaction, because during this process, heat is taken in. And an endothermic reaction is a reaction that takes in heat. Number two, we have this the situation where this same liquid changes to a solid, whereby you get water and you put it in the fridge, it freezes. So as the word suggests, freezing. So this process is called freezing, or another change of state of matter. You can also refer to this as solidification. Then we also have the change of state from liquid to gas. That is when you are boiling water and the water is turning into vapor, right? So what causes that? What causes that is a gain in heat. When you put the water on the stove, and then it begins to gain what? Heat. So this is also an endothermic reaction, which is what? Evaporation. Then we have the vice versa, whereby you put the lid on top of that vapor, then it begins to change into what? Into a liquid. That is called condensation. And during that stage, heat is lost. So that is an exothermic reaction. And then we have the change of state from gas to what? To solid. So let us first begin with the change of state from solid to gas. So when a substance changes directly from solid to gas, for example, chloride, iodine chloride, yeah, it does change directly. That's one example. You have a process that is called sublimation. Now, the opposite of sublimation, where a gas changes directly into a solid, this is referred to as deposition. So we close up this video by looking at the heating and the cooling curve. So let us begin with a heating curve. A heating curve shows how a substance changes from its state into another state after heat has been applied. So what you expect is a graph that is increasing. So the best example, or let us look at the heating curve of solid ice. So this is ice. We know that ice has got a melting point of 0. So expect to start at 0 there, right? So starting at 0, we'll have that, then that. So let's name this A, B, C, D. So we're going to name this as 100 degrees Celsius. Now, if you are heating a solid, what you expect is that it will convert to a liquid and then finally to a gas, right? So I want you to keep one thing in mind about heating and cooling curves. A line that is bent like that is a line that shows only one state of matter. So understand this. We have what? We have sorry, this would be 100 degrees Celsius. No. So this would be your 0, and this would be your 100 degrees Celsius. So now, having this diagram, we can see here that if you are starting a solid from here, it means this will be a solid, this part that is slanting, because as I mentioned, a slanting part shows that it's only one state of what? One state of matter. So when it reaches this line that is straight, it means that you have two states of matter. So in this case, we have a solid to a liquid. So you can say solid and liquid. Keep in mind that a straight line shows two states of matter, or a bent line will only show one state of matter. So if it changes from a solid to a liquid during this phase, this point at which it changes from a solid to a liquid is what we call the melting point. Those changes to a liquid. And then this part will be a liquid because it changed into a what? Into a liquid. Then that point where it changes from a liquid into a gas is what we call the boiling point. And the boiling point of water is what? 100 degrees. So during this phase, it will be in liquid and gaseous state, but in this phase, it will only be a liquid. So if you have another graph there, then you expect to have a gas. The opposite of a heating curve is a cooling curve. So for a cooling gap, you expect the graph to come like this. Why? Because this is something that was in another state and then it's being cooled to a lower state. Let's take water, for example. It's cooling so that it can become a what? A solid. So the same thing will happen. There's no big deal here. So if you have a solid there, what will happen is that in this state, this will be a solid. And then during this state, you have a solid and liquid. Then you only have a liquid three. So it depends on how your cooling or heating curve is drawn. So sometimes you may have something like this, it's longer, and it goes like this, then like that. So in this state, you have the liquid and gas because it's coming down to a what? To a gas, it's going down there. So in this state, you only have a gas. If you have the opposite there, whereby you have the gas there, then you have a gas there, right? Means here you have gas to liquid, so gas and liquid here. Then here you only have a liquid. Then there you have liquid and solid. Then there you only have a solid. So that is it about this second topic in chemistry, and see you next time.